Welcome to College Algebra. In this lecture video, we are going to continue with our section 3.1. So this is the part 2 of section 3.1 lecture video. So in this objective number 4, if we continue from what we did last time, which I show you what is a function, what is not a function, how we use the vertical line test, and we did some domain and range type of problem. So now in this in this particular lecture video, we're going to begin to talk about evaluate functions. Okay, so to evaluate functions, to evaluate a function means we will find the y value when given any x value on the function, or we can actually find the x value when given any y value. We can do it vice versa. Remember that the y variable is a dependent variable because it depends on what the input of x value is. So we can either evaluate a function by hand, by simply plugging into the function, okay, and work it out by hand, or we can graph the function and use a table. Okay, that will only work out if the x value is a whole number. So if the input x value that is not a whole number, like a fraction or a decimal, then we can use the idea of graphing the function and use the second calc function on the calculator to evaluate. Alright, so I will show you how to do all three of these just in a minute when we run into an example. So let's take a look at this, okay, real quick. This particular example, so here is the following relation. I need to rewrite the relation as a function of x. Okay, so what I mean is I need to write it as y equal. Okay, write relation as a function of x. So here I got 4 terms. Alright, so to get y by itself, so we can write it as a function of x, that means I got to, let me take a picture of this and bring it down. So that means right now my variable term is negative 5y and negative 2y. They need to be on the same side. So since negative 2 is bigger than negative 5, I'm going to move negative 5y over and move my negative 4x to the left side. So I should get negative 2y, negative 5y move over, become positive 5y. X is still x on the left side. Negative 4x come over, become positive 4x. So what I want to do is get y by itself. I need to solve for y because y becomes f of x. So I'm going to go ahead and just combine like term, but I'm going to rewrite my y on the other side. Oh, you know what? Let's just do it over here for right now. Negative 2y plus 5y is 3y. X plus 4x is 5x. So to get y by itself, we would divide both sides by 3. So that would be 5 over 3x. Okay, so this is a linear function. This is a linear function. So that means my answer will be f of x, which is the y, equal 5/3 x. Alright. So step 2, evaluate the function in the previous step at x equal to negative 3. So if I will substitute negative 3 here by hand, because this is my function, step number 2, 5 over 3 times negative 3. So I can put this in the calculator to tell me my answer is going to be negative 5. Right, the top 3, bottom 3 cancels out. Or I'm going to go to my calculator and type in 5 over 3x. When we type in a fraction, always put it in the parentheses, and then 5/3 times x. If I graph it, this will be a straight line. And let me go back to standard window for a minute. Here we go. Okay, so another way is graph it. go to second table and look up x equal to -3. So let me go back up. Alright, so the answer is -5. Or another way is this. Okay, you got your picture right here. Press second calc. Choose number 1 value. So this function in the calculator allows you to type in any x value and it will output a y value. So if I type in -3, my y value is -5. Okay, so any one of the 3 ways will work to evaluate a function. Alright, so step 3 out of 3, determine the implied domain of the function found in the first step. Alright, so this is a linear function, so my domain got to be from -infinity to +infinity. Okay. Alright, it's not too bad. Now let's try another one. Okay, same thing. Rewrite the relation as a function of x. Gotta get y by itself. Gotta get y by itself. So right now, my variable term, I only got 1, which is a -4y. So I'm gonna move it over. That means the 5 gotta come back. So that will give me +4y. Come over to, excuse me. +4y will go to the right hand side. If I move the 5 over, become negative, so that will be square root of 1 minus x. +5 come over, becomes negative. Alright, to get y by itself, divide every term by 4. Okay, that will be probably the easier way for us to put in the calculator in a minute. So on the left side I got 2 terms. So the first term, square root of 1 minus x divided by 4. Second term, -5 over 4. Alright, so this is still a square root function. Okay, so my answer for the first step, my function of x, okay, will be square root of 1 minus x over 4 minus 5 over 4. Or you can actually write it as square root of 1 minus x minus 5 on the outside in both terms over 4. Okay, so just in case if the computer show you this particular answer, that's the reason why. So we can either split the divide by 4 among the 2 terms, or we can write it as one big term where the 2 on top shares the same denominator. So evaluate at -3. So f of -3. Substitute -3 for x. So in this, you know what? I'm gonna go ahead and graph it. Okay, I'm gonna type this right here. Okay, 2 terms. Okay, I write them as a fraction. So parenthesis for the first term. Second square root. So my square root give me an open parenthesis. 1 minus x. Close the parenthesis for my numerator. Excuse me. Close the parenthesis for my square root. Then we divide it by 4. And close the parenthesis for my first term right here. Okay. So why do I have 2 parentheses open up? Because my square root opens one up automatically. But I got to make sure I close it before I type in divided by 4. Minus parenthesis for the second term, a fraction, 5 over 4. Close it. Alright, so this is a square root function. You just go the other way. So if I go to my table, evaluate -3, it'll be -0.75. Now what I'm going to do is I'm going to make my window a little bit smaller on the y value. I'm going to shrink it down. I'm going to squeeze it top and bottom. Go from -10, negative 10 and 10 to negative 5 and 5. Maybe it'll pop out a little bit better. Oh yeah, that's much better. So this is a square root function, just going in the opposite direction. So where does it start? Well, it doesn't start. It actually starts from the left side because we write the interval notation from left to the right. So this problem, where does it stop at? So where does it stop? Okay, all we gotta do is set what's inside the radical equal to 0. That will tell me where does it stop. So if 1 minus x side equal to 0, move the negative x to the right side, then x is equal to 1. Okay, we can double check. Go to your table. Okay, at 1, alright, is negative 1.25. So I wonder what happened at 1.1 for x. So go to second calc, number 1 value. Let's check out 1.1. Nothing. Okay, when there shows nothing, that means the function does not exist at 1.1 for x. Okay, so that means my function stops at x equal to 1. So for my domain, coming from the left side, small to large, my domain will have to be from negative infinity all the way to 1. And 1 is actually on the line because you just saw when x equal to 1, there's a y value actually exists. So I use a bracket. Alright. Now let's look at a rational function. Okay. Not quite rational function. This is actually a linear equation because I got x and y on the numerator rather than on the denominator. So let me rewrite this. So currently I got 2 terms. Okay, to get rid of the 4, I will multiply both terms by 4 because the top 4, bottom 4 will cancel out. So the left side would just be 3x minus 2y equal to 20. Alright, to get y by itself, since this is a negative 2, I will move it over. So that will be positive 2y on the right hand side. Move the 20 over, that will be 3x minus 20. Divide every term by 2. My y is equal to 3 over 2x minus 10. So my function f of x, which is y equal, would just be 3 over 2x minus 10. Alright, I know this is going to be a straight line because this is a linear function right here. So when I evaluate x at negative 3, so substitute x for negative 3, that will be 3 over 2 times negative 3 minus 10. So if I go to my table, if I actually graph this linear function and go to my table, it'll give me a decimal. It'll actually give me a decimal answer. Or I can just put this part in the calculator straight up by saying parenthesis 3 over 2 times negative 3 and then minus 10. That will still give me my answer, negative 14.5. So we can do negative 14.5, or we can do probably improper fraction. Math number 1, convert to fraction. Oops. Negative 29 over 2. So that all depends on what the homework wants, either a decimal form or fraction form. Alright, so since this is a straight line, if when you graph it, then my domain got to be from negative infinity to positive infinity, just like the first one I did earlier right here. Okay, oops, sorry. So if you know what the function, if you know what the picture looks like by reading the function, then you probably you can just go ahead and write down the domain without graphing it. If you're not quite sure, graph it. graphing. All right, so let's do some evaluating without numerical values. So these are just algebra type of work. So determine f of x squared for the following function. So I'm going to substitute x for x squared. That means every time I see an x in my function, I will replace it with an x squared. So f of x squared will just be square root of, okay, this is two terms in here. Substitute x squared for that x. So that'll just be x squared straight up plus 5 and plus 4 on the outside. Okay, that's all you can do. Because this x squared plus 5 cannot be simplified anymore. You cannot factor it and then things will cancel out. Let's try another one. Substitute x for x minus 1. So every place I see an x, I will substitute for x minus 1. So that will be h of x minus 1. That will be 4, right? 4 times x. Now the x will be replaced with two terms representing one variable I substitute. So I still got to keep my x minus 1 in the parentheses. Okay. Over, alright, substitute two terms for one variable x right here. So keep my x minus 1 in the parentheses, square on the outside, because the square is on the outside of x. So you got to be on the outside of x minus 1. Minus 4 times x minus 1 plus 3. So earlier, the previous problem, when I substitute x squared for x, I did not use a parenthesis because this term x alone is not being multiplied by anything up front. Plus x squared is one term substituting for one term. You don't really need a parenthesis. Now, if let's pretend I have something like a 4x plus 5, and I want to put the x squared in this place, then yeah, maybe I will put a parenthesis. Okay, but normally one term for one term substitution, you don't really need a parenthesis for it. So let's simplify. Okay, the top, let's do a distribution real quick for the top. That will be 4x minus 4 over. Alright, so during the review we talk about this term right here is a perfect square binomial. Perfect square binomial. Remember the formula? A minus b whole thing squared is equal to a squared minus 2ab plus b squared. So it'll be a lot easier if we can just write it out, the answer straight up. So this is going to be x squared minus 2ab, take a number 2 times your a times your b. That will be minus 2x plus your b, 1, got to be squared, which is 1. Second term, do a distribution. That will give me negative 4x and positive 4. And my third term is still a positive 3. Alright, so top is still 4x plus minus 4 over, if I will simplify, if I will combine like term down here, I believe x squared is still x squared. Negative 2x minus 4x, negative 6x. Let's see. 1 plus 3 is 4. 4 plus 4 is positive 8. Okay, so what do I do from here? Well, we need to see if we can factor my numerator and denominator, so maybe somebody can be canceled out. I don't know yet, so let's try the bottom. I know the top is going to be 4 times x minus 1, but let me see what the bottom is. If it's not going to work out, I'm just going to leave it like this. X and x, 8, 2 and 4. Now my inner and outer combined will give me my 6. So to get negative 6, both are negative. So if I factor the top, I will still go back to 4 times x minus 1. So nothing can be reduced. Okay, so this can be your answer, or this part can be your answer. But you still got to try it, though. You still got to try to factor it out to see if anything can be canceled out. Not in this particular problem. All right. Now this one is finding determine f of x plus a minus f of x. So what's going on here is we need to evaluate, okay, at x plus a, and then we're going to end up subtracting our original function, which is the f of x. So remember, f of x is your function. Okay, so let's do the first part. Okay, evaluating f of x plus a real quick. So I'm going to do it right below here, and then in a minute I'm going to write them together so I can combine like terms. So substituting these two terms for x, so that will be square root of x is now going to be x plus a. I can put a parenthesis around these two, but what's going to happen is the one up here eventually will do a distribution, so it will still end up with the x plus a. So parenthesis is not really necessary here, so I'm just going to write x plus a. Alright, positive 3 still inside the square root, plus 4 on the outside. Alright. So there's nothing can be simplified here, so I'm just going to line it up with minus the f of x. So my f of x plus a is all these. I'm going to erase this part. Minus my f of x, which is still this. Be careful now. If I write out my f of x, it looks something like this. But my f of x is two terms, okay, representing one thing I'm subtracting. So technically I got to put them in the parentheses. So when the negative 1 do a distribution, okay, this positive 4 will turn into a negative. This positive square root x plus 3 will turn into a negative. So if you know that ahead of time, what you can do is go ahead and what? Distribute. That means changing the sign for the positive 4 into a negative. Alright, so what's going to happen here is the positive 4 and the negative 4 will cancel out. So that would just leave me with square root of x plus a plus 3 minus, okay, square root of x plus 3. Okay. Alright. And then of course you can do the same thing for this particular one. Well, let me work this one out because this one has got the negative 4x squared up here. So let's do the same thing. G of x plus a, that will be negative 4, substitute x for x plus a, so that will be negative 4 times x plus a, whole thing squared, minus 5 times x plus a. Minus 4. Alright, so x plus a whole thing squared. So this is another perfect square binomial. So that will actually give me x squared plus 2ab, that will be 2xa plus b squared. Alright, with a negative 4 in front, do a distribution on these three terms. I should have negative 4 x squared minus 8. Right, negative 4 times positive 2, negative 8xa minus 4, excuse me, I did not mean to say B right here. It's an A, because my B is a letter A. Minus 4A squared. Alright, second term, negative 5, do a distribution, negative 5x minus 5a and minus 4. Okay, let's see if we got any like term to combine. No, not really. Is there any? No, don't see it. Alright, so all these guys, alright, is what's come out of g of x plus a. Now the g of x plus a gonna minus the original function. So I'm gonna put it right here. Now I'm gonna say minus, okay, the original function, all three terms in the original function are negative. So for the negative one, do a distribution on these three terms. That will be a positive 4x squared plus 5x plus 4. Okay, so I basically just did not write minus parenthesis negative 4x squared and so on. Okay, because then that would be give me an extra line when I already got everything flying everywhere. So we go ahead and distribute, you know, as we write out the subtraction part right here. Now let's see what can happen. Combine like terms. Negative 4x squared plus 4x squared cancels out. Minus 5x plus 5x cancels out. Negative 4, positive 4 cancels out. So all I got now is my negative 4a squared, okay, minus 8xa minus 5a. Okay, so and if I want to go a step further to simplify this, I can say, well, since every term is negative, I can factor out a negative. Since every term has a, I can factor out an a. Okay, because this stuff is actually going to be used for another problem here in a minute. So that gives me positive 4a plus 8x plus 5 if I just factor out a negative a. Or I can factor out a positive a and just have these signs negative. Okay. Now, one of the reasons why we couldn't do any factoring here, because inside this square root you got a plus a there, so these two terms is actually different. Okay, there's no common factor between the two terms. All right, so we do all this work because this course, part of this course is called the pre-calculus, because these are some of the arithmetic that you need for the calculus course. And one of the biggest things we talk about in calculus is called the rate of change. Alright, rate of change is basically like the slope formula you ever heard, you heard before. The slope formula says y2 minus y1 over x2 minus x1. Okay, so this formula is very similar to the slope formula of a linear function. You can see that subtraction right there. Alright, so the difference of quotient of a function is using this formula. So now what we just did applies to a problem like this. Okay, without the h down here, if we just look at the top up here, remember earlier we did the x plus a, now we're just gonna call it x plus h. Then we're gonna line it up saying minus f of x, the original function. And then we're going to divide it by h at the very last. So here's my original function, f of x, that will go in this spot in a minute. So let's figure out what is the x plus h. So substitute x plus h for every x you see. That will give me negative 5 times x plus h minus 3. Alright, if I do a distribution, then what I should get is negative 5x minus 5h. minus 3. Okay, so this is going to be the f, these three terms going to be where the f of x plus h is going to be at. So we're going to line it up. And minus my f of x, which is original function. So this subtraction sign do a distribution on these two terms, that will be plus 5x plus 3. Whole thing over my h. Alright, so now the difference between here versus the previous one we just did is I didn't have an h in the bottom, something like that. So all I'm going to do now is simplify my numerator like I did earlier. So let's see what happens. The negative 5x plus 5x will cancel out. Negative 3 plus 3 will cancel out. So now I got negative 5h on top over h in the bottom. So since I already have one term over one term, I can reduce my h. So my final answer would just be negative 5. Okay. Alright, so if we try a similar one with a negative 3x squared plus 2x plus 6. Okay, still using the same formula, okay? X plus h first. Alright, so that would be negative 3 times x plus h squared plus 2 times x plus h plus 6. Alright, so again, perfect square binomial right here will give me x squared plus 2xh plus h squared. Alright, with a negative 3 in front, do a distribution on these three terms. I should have negative 3x squared minus 6xh minus 3h squared. Alright, positive 2 do a distribution, positive 2x, positive 2h, and the positive 6 as my third term. So I don't think there's any like term to combine here. So all these guys will be the f of x plus h. Now we need to minus my original function f of x. So that minus sign, that negative 1 do a distribution on these three terms. Okay, we'll change the sign. So let's write it out. So all this f of x plus h now will minus my original function, negative 1 distribute, that will make my negative 3x squared a positive 3x squared. Positive 2x become negative 2x. Positive 6 become negative 6. And everybody is over h. Alright, combine like term. Negative 3x squared, positive 3x squared cancels out. Positive 6, negative 6 canceled out. Positive 2x, negative 2x cancels out. So what I got left on the top is negative 3h squared. I'm going to go ahead and put this h squared term up front, okay? Minus 6xh plus 2h. Whole thing over h. Alright, so the greatest common factor here is an h. Okay, so I can actually factor out I'm going to factor out a negative h to the outside. So that would just be positive 3h left for the first term. Okay, positive 6x, the h went outside, and the negative 2. Whole thing over h. So I could do a negative, or I don't have to factor a negative here. Doesn't matter. Alright, so what I want to show you is make the whole numerator into one term before you cancel out the h's on the outside. Okay, so my final answer can be negative 1 times 3h plus 6x minus 2, or if I did not factor out the negative, I would just end up with negative 3h, negative 6x, and positive 2. So either answer is actually correct. Okay, either answer is actually correct. Alright, so a little bit of rate of change and some evaluating in this lecture video. So a lot of algebra that we reviewed does come in play here. Alright, thank you for watching this lecture video.